Hi guys, this is Mrs. Delis here again. Welcome to another lesson of Algebra 2. In this lesson, we're going to learn how to use completing the square to rewrite a quadratic function in standard form into vertex form. Before we dive into learning what perfect square completing the square is, let's learn perfect square trinomials. Perfect square trinomials are trinomials that can be factored into the form a plus b squared or a minus b squared. Below are some examples of perfect square trinomials. And they're called perfect square trinomials because for one reason, if you look at their c values, they are all perfect squares. So 16 will give us 4 times 4. 25 will give us 5 times 5. 100 will give us 10 times 10. 144 will give us 12 times 12. But if you take a look in here, 4 times 4 for 16. For the first example, we have x squared plus 8x plus 16. And we have an x plus 4 and x plus 4. So if you notice, they're both positive 4. And so we can just write them here. We can combine the two binomials and call it x plus 4 squared. Right? Like, let's say, for example, you have 4 times 4. That is 4 squared. Right? Or 6 squared is the same as 6 times 6. So instead of writing it as an x plus 4 times x plus 4, I could write it as x plus 4 squared. Does that make sense? All right. Now, but why both positive though? Because you know how 4 times 4 gives you 16. Negative 4 times negative 4 will also give you a positive 16. But why do we have it a positive 4? But because our b value is a positive 8. Right? If our b value would be a negative 8, like say if I have x squared minus 8x plus 16, then my answer would have been an x minus 4, x minus 4 squared. Does that make sense? So just like another example for the 25, we know 25 is a 5 times 5, but why do we have a negative 5 in here? The reason because we have a negative 10 in the middle. So if that was an x squared plus 10x plus 25, then I would have to give x plus 5 and x plus 5 in my final answer. Okay? Now, the question is, what is the relationship between the b value and the c value? Or in other words, if I know the b value, can I predict my c value? Does that make sense? So if I have x squared plus 8x, and then my c value is missing, and then how do we make a perfect square trinomial? We know that a c value has to be a perfect square. Now, 49 is a perfect square. Can I put 49 in there? 81 is a perfect square. Can I put 81 in there? Because there are all perfect squares. But why it has to be 16? Okay, does that make sense? Why it has to be 16? The partner here, why it needs to be 16? The reason behind that is because you need to have a perfect pair, right? 4 and 4, negative 5 and a negative 5. So how do we determine the C value? Very easy. All you have to do is divide the B value by 2 and then square that answer. Let's see if that works. So if you have 8 divided by 2 and square that answer, 8 divided by 2 is a 4. 4 squared is 16. And so the number that would make this a perfect square trinomial is that if 16 is our b value. Do you think that works on every single perfect square trinomial? Let's try the next example. X squared minus 10x. So if we divide the negative 10 by 2, we will get negative 5, correct? If we square that, negative 5 times negative 5 will give us 25. And we got 25 as the C value. So the one that will make this a perfect square trinomial is that if we have a 25. And hopefully you're getting the idea. Let's try this one. X squared minus 6x plus, we don't know, and x squared plus 12x plus, we don't know. What would be the number that goes there to make it a perfect square trinomial? So let's try negative 6 divided by 2 and square. Negative 6 divided by 2 is negative 3. Negative 3 times negative 3 is a positive 9. So for it to be a perfect square trinomial, we need a 9 in the C value. What about over here? 12 divided by 2, that is 6. 6 times 6 is 36. So we're missing a 36 for it to be a perfect square trinomial. Okay, does that make sense? All right, let's try to use completing the square to rewrite each functions below. Right, our goal is to have a perfect square trinomial. Negative 9. So if I have negative 8, let's try that. Negative 8 divided by 2. So technically, the formula is b divided by 2 and square that. Because the b value is a negative 8, right? So negative 8 divided by 2 and square that. Negative 8 divided by 2 is negative 4. Square that, you'll get 16. Because negative 4 times negative 4 is positive 16. Now we have a problem. It's not negative 16, it's a negative 9. So our goal is to get rid of the negative 9 because we're changing that into a positive 16. So we can have a perfect square trinomial. So what are we going to do with the negative 9? We need to kick that out. So in order for us to kick that out, we're going to kick that out to the left side. So what should we do? Should we add 9? Yeah, let's try to add 9. So if you add 9 on both sides, whatever I do to the right, I'll do to the left. So I have f of x plus 9 equals x squared minus 8x. Now I don't have the negative 9 in there. Now I can move this 16 into there. Does that make sense? So I'm going to do f of x plus 9. And I'm going to add 16 there. Now I have a perfect square trinomial, correct? That whatever I do to the right, I will do to the left. So because I have to add 16 to the right side, I'll have to add 16 to the left side. That makes sense? Okay, now let's add what's 9 plus 16. So that's f of x plus 25 equals, we can factor this out. What gives us 16 when we multiply? Gives us negative 8 when we add. Very easy. Because this is a perfect square trinomial, we need the first parenthesis, the first factor is the same with the other one. So that is an x minus 4. Does that make sense? Or they're the same, so we can just write them one time, right? So let's try to write that one time. Plus 25 equals x minus 4 squared. And now I think we have to bring back the negative 25. The positive 25 to the other side. So what should we do? Subtract. And our final answer would be f of x equals x minus 4 squared minus 25. And this is what you call the vertex form. And this is now, you just finished processing it with using completing the square. And this is what completing the square is about. Okay? Completing the square is technically solving quadratic equation, the standard form, making it into a vertex form. And we already have the vertex form. Okay, let's have another example. Let's try another one. We have f of x equals x squared plus 4x minus 12. And we need to make a perfect square trinomial. So let's see. Oh, 12 is not even a perfect square. So let's see what number should go in there to make it a perfect trinomial. So 4 divided by 2 squared. 4 divided by 2 is 2. 2 squared is a 4. So we need to add a 4 in there. 4 will make the trinomial perfect. But right now, we don't have a 4. We have a negative 12. So we need to kick out the negative 12. So we add 12 on both sides. So we have f of x plus 12 equals x squared plus 4x. And now we have a space for our 4 to come in. So let's put that in. F of x plus 12 equals x squared plus 4x. Now I can put my 4 in. And again, whatever I do to the right, I will do to the left. So add in plus 16. And I am looking for a number that when I multiply, I'll get positive 4. When I add, I'll get positive 4. Well, that's too easy, isn't it? So x plus 2, x plus 2. Easy, huh? And then, because they're the same, remember earlier, when they are the same, we can write them as one time. And then what else do we need to do? I think we need to kick out the the positive 16. So let's kick that out. Minus 16, minus 16. So our final answer is x plus 2 squared minus 16. Okay? Make sense? More example? Let's have more examples. 2 more examples. So let's do 10. Is 10 a perfect square? Nah, 10 is not a perfect square. What would make this a perfect square trinomial? Let's try. Let's use our formula b divided by 2. So our b is a negative 14 divided by 2. What's negative 14 divided by 2? That's negative 7. Square that, you'll get 49. So the one that would make it perfect is that if we have a 49. But it's not 49 yet. So we need to give a space for 49 to come in. So we need to kick out the positive 10. So we need to minus 10 on both sides. So we have f of x minus 10 equals x squared minus 14x. And we have f of x minus 10 equals x squared minus 14x. And now we have a space for the 49 to come in, plus 49. And whatever I did to the right, I will do to the left. So you have f of x, is that a positive 39, equals, what gives you 49 when you multiply? Positive 49 when you multiply. It gives you a negative 14 when you add. And make sure the numbers have to be the same, and the numbers have to be the same sign and the same value. So they are x minus 7 and x minus 7. Okay, so this is f of x plus 39, x minus 7 squared. So what else do we do? Oh, we could kick away the negative 39, minus 39 on both sides. So we have f of x equals x minus 7 squared minus 39. Okay? And that is our final answer. This is called the vertex form. Let's name them one. This is called the vertex form. Okay? Now, oh, last one. Is this, oh, 1 is a perfect square, right? 1 is a perfect square, but is that a perfect square trinomial? Let's see. What do we divide the 4? So b divided by 2 and square. So 4 divided by 2 is 2. 2 squared is 4. So the one that would make it a perfect trinomial is if we have a 4 in it, but we don't. So we need to kick out the negative 1, correct? So let's kick out the negative 1. What should we do? Should we add 1 on both sides? Okay, let's add 1 on both sides, plus 1, x squared plus 4x. Now we have a space for our friend 4 to come in. So we have f of x plus 1, x squared plus 4x plus 4. And whatever I added to the right side, I will add to my left side. So I will end up with 5. Oh, this is super easy. Because I think we did that one. Did we do that one already? Right here on the other page, right? So what gives you positive 4 when you multiply? Gives you positive 4 when you add. Easy, easy. Positive 2. Correct? And so I can have f of x plus 5. And remember now, I can write that one time. So I have f of x. We need to move this negative, the positive 5 away. X plus 2 squared minus 5. And now you have the vertex form. Okay? Not that bad, right? So I think completing the square is super easy. It's like easier. I felt like completing the square is even easier than quadratic formula, which we will be learning also soon. And I hope this video makes you help you how to complete the square. In the next video, I'm going to be covering how to complete the square when the a value is not equal to 1. You know how in these examples, we just have x squared, x squared, x squared. We don't have like a 2x squared or a 3x squared. Okay? Thank you guys for listening. And your homework is on the next page. And I will see you on the next video. Thank you.